Hello, everybody. You have this new tool called the unit circle. Let's learn how to use it. So we're going to solve some problems today looking at the unit circle and pulling the information off of that. That is replicating what the calculator will do for us. So today is all about seeing what the calculator is going to look at, pulling that information, and then hopefully when we start using the calculator and we don't have to use our unit circle, you understand what you need, what you're getting, and what you might need to add to it. So we're also going to throw in a very fancy thing. If you want to look cool in front of all your friends, you say, hey, the trigonometric Pythagorean identity. It's a fancy word, fancy way of saying a squared plus b squared equals c squared. Cool, let's rock and roll. All right, so this should be at your fingertips. You should know kind of what it represents, how it's used, maybe some of the things that you can solve for. So for instance, if I asked for the sine of pi over 6, I'm asking you for the y coordinate of the point formed on the unit circle. So the pi over 6 is right here. I see that we have an x and a y coordinate. The y coordinate is associated to the sine value because it is the opposite over hypotenuse. Remember, the hypotenuse is 1, so that is equal to 1/2. Very cool. All right, so I would stop the video right now, print one of these out if you haven't already, or filled in the one that you have. You're going to want to reference it. All right, so here we go. This might be a good opportunity to show you how that is represented. So these are all problems off your homework that we skipped a lot of these, but I'm gonna have you do a few. So this is written cosine squared pi over 4 minus sine of pi over 6. So basically all you have to do is go get the values. I've done that for you. Right, underlined in red here, I see that this value is right here, and the sine of 7 pi over 6, so I go to 7 pi over 6. I see the y value is negative 1/2. Cool. All right, so just to show you some notation, the squared is weird. What's going on with the squared? Well, the squared, the way we do trig functions is we put it over the trig function, not really the argument or the angle, because we don't want to confuse you. Do you square the angle, then take the cosine? So that 2 is really means this idea. Find the cosine of pi over 4 and then square it. Okay, and then square it. So I wrote it out there for you. Um, so we just find that square root of 2 over 2, that's this value. We're going to square it. Minus the negative 1/2. Remember the negative. Then we just add, subtract, do our thing, and we get that that is equal to what? All right. What I would like you to do right now is solve B. Solve B. You'll see that on Play Pause It. Okay. Well, hopefully you got it right. Let's check it out. If you did sine of pi over 6, you noticed that in purple here, the sine of pi over 6 is this value, and the cosine of pi over 3 is this value. We just plug those in, multiply them, we'll get 1/4. So hopefully that works out for you. Let's try another one. So this is now saying find the angles. So we're working it from different angles. Okay. All right. So this is saying we know that the cosine of the angle is equal to -1 over the square root of 2. So another way to writing this is theta is equal to -1 over the square root of 2. So we're asking ourselves what angles will give us that value for the cosine. Remind you that these are equivalent forms. So what I need to do is go to the unit circle and look for x coordinates that have a negative square root of 2 over 2. And I find it here, and I find it here. All right. So the first angle that I found is right there. And that's going to give me 135 degrees or 3 pi over 4. And the second one is if I go to there. 225 degrees or 5 pi over 4. So the answer to this one is actually just these. We wouldn't put the degrees. I'm trying to work backwards and forwards with you. Why is that? Because it implies, since they asked between 0 and 2 pi, that we're working in radians. If we were asked 0 to 360, then we'd work in degrees. Try to work in both for a while just to kind of help yourselves out. All right now, I would like you to go find all the angles that have a sine value of square root of 3 over 2 that land between 0 and 2 pi. Okay, hopefully you did great. Here's what I got. Um, Notice that the y value is square root of 3 over 2. That's easily seen that those are 60, 120, pi over 3, 2 pi over 3. Awesome. Unit circles, just giving it away, giving it away. Now, what is your calculator going to do here? You know what I mean? So, you have this sine theta is equal to square root of 3 over 2. You know you can take the inverse sine, and probably it's going to kick out 60 degrees. But what do? Hit enter again to try to get it to say 120? No. So we got to kind of notice some patterns as we go with sine and cosine. I'll illustrate that next class. All right. So a couple things to notice about this particular problem. We're going to find all angles between 0 and 4 pi. Remember, we can go 0, we can go around once, we can go around again, we go around again. Every circle is 2 pi. So we want to know what angles sine of theta is equal to -1/2. So we're asking ourselves what angles have this y coordinate of -1/2. All right, so I've kind of illustrated these already. They are the y values of -1/2 right there. So if we want to see those angles, there's one of them. And there's the other one. So cool. Just like the problem before, 210, 330, 7 pi over 6, 11 pi over 6. Your inverse sine of -1/2, interestingly enough, is going to give you something that doesn't even land right here. So we really have to understand what we're finding visually so that when we use our calculator, we can kind of understand what it's telling us and then how to go from there. All right. But we have to now think about, well, what if we go around again? Well, that's simple enough. What we're going to do is think about it. If you want to draw it, you can. That inside one, just think we're doing an angle that goes woo and then continues around and lands right there where we have that -1/2. So all we're going to do is take our degrees and add 360, or our radians and add 2 pi. So we get 570 and 19 pi over 6. You'll get used to changing 2 pi with the denominator, since we're adding it to a pi over 6. 12 pi over 6. If we were adding it to pi over 3, it would be 6 pi over 3, that 2-to-1 ratio. So, something to notice. That's for that first angle. And then, of course, I had to get in the way of this. Let's move over here, I guess. And look at this bad boy. This thing goes around and around and around, it seems like. But don't stop there. Go another full circle, and you end up there. So once again, you add 360 or you add 2 pi. Now you would continue to do that until you're outside of the given range, So 0 to 4 pi, those are all the angles that are going to be between that. All right, why don't you try A right now? List all the angles between 0 and 4 pi. Thank you. All right, hopefully that went well. This is what I got. You simplify this as you go. Obviously, we have a cosine of square root of 3 over 2 there and there. So it's pretty easy to identify those in degrees and radians. Whoa, whoa, and radians right off the unit circle. And then now, because it's not 2 pi, it's 4 pi, another circle, we just add a full circle and we get our next two. Because this is in radians, our answers would really be the 4 in red. All right, nice job. Unit circle, just it's working for us. It's working for us. All right, this looks a little bit more challenging, but I got to tell you, I think this is almost easier because we really love it when this is 0 to 2 pi. Then we really are going to be searching for these two angles. You know, the first angle is the easy one to see, then that second angle. Pictures always help, always help. All right. So this is a tricky one. That's why I picked it. Cosine squared theta equals 1/2. We've been working with cosine theta equals something or sine theta equals something. So algebraically, that's the first thing you have to do is break that down. We'll take the square root of both sides. And really, we break it up into two problems then. Two problems. So we have case one where the cosine of theta is equal to positive square root of 1 over the square root of 2, or as we now know, that is right here and here, or where the cosine of theta is equal to negative 1 over the square root of 2 or square root of 2 over 2, and that's written right here and right here. Well, we can list those angles now pretty easily, and life's pretty good. All right, hopefully that's working for you. It's the same thing over and over again. You're working backwards and forwards. All right, let's keep this ball rolling. Oh, I was going to have you do one. This is kind of an easy one. Square root of 3 over 2, boom. Square root of 3 over 2. The y values are the same, so I see that as pi over 3 and 2 pi over 3. All right, wanted to readdress this and make sure that we're all on the same page about the whole positive, negative, and why that might be important. If the angle is in the first quadrant, if the angle's in the first quadrant here, we know that sine of theta, cosine theta, and tangent theta will all be greater than 0. So we put an A there to represent all three. If we have an angle that is in the second quadrant, think about it. The x coordinate's going to be negative, the y coordinate's going to be positive. So that means the sine of theta is going to be greater than 0. Remember, tangent is sine over cosine. So if you have a positive over negative, you're going to get a negative. So the only thing positive in this quadrant is sine. Okay. If you're in this quadrant, you're going to have a negative x and a negative y. When you do a tangent, you're going to get a positive. So the only thing positive in that quadrant is tangent. I think I said that weird. And then finally, in this quadrant, if I'm right here, the only thing positive is going to be that x value. They'll have a negative y value. So the cosine theta is greater than 0. So a lot of people remember ASTC. All students take calculus, and that kind of tells you, hey, if you know your angles in this quadrant, you know that the sine's going to be positive, cosine, tangent are negative. Or more importantly, if you're told that the sine value of the angle is positive, that limits the quadrants that you can find. I'll say that again. If you're told maybe that the sine of theta is positive, then you're limited to where you can look for the angles that satisfy that situation. Sine is only positive in this quadrant and this quadrant. So when we're trying to satisfy our situation, we can only pick angles that are in that if we're given that. So something to think about. Let's see it in action. All right, so the Pythagorean identity is nothing more than the Pythagorean theorem. I hope that you can recognize that x squared plus y squared equals 1 squared all day long squared. So that is true. We know that the cosine is equal to x, sine is equal to y. We write it, I kind of write it like this to show you that I'm just plugging in for x, but as I discussed earlier, we never write that notation. We write that like cosine squared theta. It means find the cosine of theta, get that value, and then square it. So be careful. How are we going to use this? Example number 1. You're given sine of theta equals 2/3. I'm not asking you for theta. Be very careful here. I'm not asking you for theta. I'm asking you for what is the value of the cosine of theta. So what's the picture look like here? The picture looks like we know the y coordinate is 2/3. But Mr. Sayers, that's not on my unit circle. You're welcome. I know that. So don't look for 2/3 on your unit circle. This is an angle that it's not exact. It's not a multiple of 30 or 45. Don't care. What I care about is if I know this y value, the question is what is this x value or the cosine of theta? Let that sink in. All right. So all we have to do here is use this. That will always be true. Okay. So we plug in 2/3 for sine. 2/3 is 4/9. 1 minus 4/9 is equal to 5/9. That's where we're getting this. We take the square root of both sides. Square root of 9 obviously is 3. So what we get here, whoa, shoot. What we get here is that value, the cosine of theta is equal to square root of 5/3. But since we know that it can be negative, then we also get that value, negative square root of 5/3. We should expect to have two angles that satisfy that. All right, going fast, but that's okay. So hopefully you can see that I have this angle. I have this angle right here, and I also have this angle. They both have a y coordinate of 2/3, so this allows me to go get it. I'd say the biggest problem is people want to know what angle it is. It's not asking you for the angle. It's asking for the x coordinate, the cosine theta. You can see that these problems that you're going to do tonight are basically all the same. You're going to use cosine squared theta plus sine squared theta is equal to 1. If we randomly pick one of these, let's say that one, we would plug that in, -3/4 squared plus sine squared theta is equal to 1. Square that, 9/16 plus sine squared theta is equal to 1. Subtract. 1 is the same thing as 16/16 in most universes. If I subtract that, I get 7/16. When I take the square root, I got to take plus or minus. That's going to give me plus or minus the square root of 7/4. Now that is not a value on your unit circle. It's a very cool value. It just turns out on the unit circle somewhere you have a cosine value of -3/4. Whoops. And so it can be this angle or this angle. That is really bad. They both have an x coordinate of -3/4. And they have different, and they have the same y coordinates because those are equal in a world, really cool universe that we don't live in right now. All right. And I did that for you. I just wanted to kind of do it live. There's a better picture, right? So we know this length here is -3/4. That's the x coordinate. So that's the x coordinate at that point and that point. So you got to figure out the y coordinates. And when we did that, square root of 7 over 4, negative square root of 7 over 4. Did I say that? It just doesn't seem like I did that right. Yeah, I did. All right. And then visually you can see that those uh, two angles. Now once again, I'm not looking for the angles. I'm looking for the sine value. The sine value. Example 9, it's in your book. We're running at 20 minutes here, so I'm going to call it. Just read through that. If you can read, you can cook, right? So if you can read, you can do mathematics. I will point out a really cool thing is these are the exact same problems we've been doing, right? Plug it in, do that, great, plus or minus, we're good. Um, but I wanted to point out this idea. They're saying, I only want the cosine value where the angles between 0 or pi and 3 pi over 2. So you have to understand what quadrant is that? Well, here's pi, here's 3 pi over 2. They're saying we only want this angle, angles that deal with that. Fine, that's great. Well, what's important about that is the cosine value, we're going to get two values right here. But since we're telling you that the angles in that third quadrant, which values are going to be positive? All of them in first quadrant, only the sine and only the tangent. So only the tangent is positive. So we say that the cosine of theta is equal to negative square root of 7 over 4. It forces it to have one value. Hopefully that helps. So have that all students take calculus kind of up on your upper right hand corner, and it really helps. Example 10, the only thing I want to point out here is tangent's equal to sine over cosine. Great. Well, we know it's equal to negative 2. Great. That means I can look at this side of the equation, get sine in terms of cosine. Sine in terms of cosine, and guess what? It's called the Pythagorean trigonometric identity for a reason, because we're going to use it every time. So we plug it in. Everywhere we see a sine, we put negative 2 cosine theta, and we keep that, solve that for cosine. That's it. So we will certainly do a lot of these in class. Hopefully you kind of have an idea of where we're going. I think with a little practice, you'll get it. Thanks. Have a good day.